The properties of gases can be explained on the basis of kinetic theory of gases. Okay, so how this is advantageous, where it is applicable? This kinetic theory of gases is applicable for the explanation of properties of the gases. What are the properties of the gases? Pressure, volume, temperature, they are the major properties of the gases. And also they have interrelation between them. Okay, so this pressure, volume, temperature, they have interrelation between them. They have the interrelation. Okay. So according to this theory, a gas is a collection of large number of molecules which are identical and are in state of continuous random motion. Okay. So according to this theory, a gas is a collection of large number of molecules. So huge number of molecules are present in a gas material or gas sample, and those molecules are perfectly identical and they are in a state of continuous and random motion. Continuous motion means they will not become stationary. They will not stop. Continuously they will move from one position to another position, and their movement is also random. Okay, they are randomly moving. Okay, so they will move randomly, right? So that is the point about this is the second point. So how molecules are in nature and how they move. Okay, that is based on kinetic theory of gas. That is the second point. Third point about the size. So basically, first point gives you where it is applicable. It is applicable to gaseous material. Second says it is applicable. How the gas molecules look like. They are perfectly identical, and how they move. They move continuously and they move randomly. Third point gives you the concept about the size of the gas molecule. So the gas molecules have a size of the order of 2 into 10 to the power minus 10 meter. That is of the order of angstroms. And the distance between the molecules is of the order of 2 into 10 to the power minus 9 meter. That is 2 nanometer size. Okay. So what it says, the size of the molecule is very small compared to the distance between the molecules. Okay. The molecules are separated by a distance of the order of nanometers, and size of the molecule is of the order of angstroms. This is very important assumption, and by practice or in nature, this concept holds good in practice also. Okay, so it says that size of the molecule is very much smaller compared to the distance between the molecules in a sample, in a gas sample. So therefore, the gas molecules can be considered to be moving freely with respect to each other. So they will move freely. So there is no interaction between the molecules. Okay, they will move continuously. They will move freely. There is no interaction between the molecules. Okay, so even though they suffer collision, if one gas molecule collide with the other gas molecule, so there is no loss of kinetic energy. That I have discussed in the previous class also. There is no loss of kinetic energy, means the collision is perfectly elastic. So elastic collision is going to take place in case of the collision of the gas molecules. So just you look at the third point. However, during the motion of gas molecules, they come close to each other and they suffer a change in their velocities due to the collision between the molecules and with the walls of the container. So definitely there is a possibility of collision. Okay, collision will take place. But during the collision, there is no loss of kinetic energy. They may transfer the kinetic energy to the other molecule. The total kinetic energy of the system remains constant. So what it says, the kinetic energy is conserved in a gas sample. So that is one more assumption in kinetic theory. Okay, so total kinetic energy of the gas system remains constant. Remember, total kinetic energy. Okay, so it assumes that it is moving freely. That means there is no potential energy for the gas molecules. Potential energy is not observed for the gas molecule. So here their size is very much smaller compared to the distance between them. Because of that reason, they will not bear any potential energy. Okay, because of their very small size, potential energy is considered to be zero. So because of that, they gas molecules can have only kinetic energy. That kinetic energy ಮಾತ್ರ ಇರ್ತದೆ, potential energy ಇರುವುದಿಲ್ಲ. So that kinetic energy is conserved. So that will not change during the course of motion of the gas molecules. Gas molecules move ಆಗ್ತವೆ, ಆದರೆ kinetic energy will be conserved. Okay, so these are the things we have discussed in the previous class. This is the recap. ಇದು last class ಅಲ್ಲಿ ಮಾಡಿದ್ವಿ. Okay, next, these are the points. Assumptions of kinetic theory of gases. Okay, what are the assumptions or postulates of kinetic theory of gases? You can make the screenshot of this one. You can take the screenshot of these things. This first slide contains 4 points. I will discuss one by one. So total 11 points are there. So it will be helpful if you take the screenshot of these slides. Okay. So first point says all the gases are made up of large number of identical, minute, invisible, and perfectly elastic particles called as molecules. So how the molecules are? So what is the nature of the molecules? That is given by first postulate. So large number of identical particles are there. They are called as molecules. So that all molecules are identical. Minute means they are very small in size. Invisible means that is also giving the nature of the molecule, that it is very, very small in size. Okay. Sorry. Okay. And they are perfectly elastic particles. They suffer collision, but they suffer elastic collision. There is no loss of kinetic energy. So that is the major properties of the molecules. So they are very large in number. Molecules are the building blocks of gas. Second point says the size of the molecules of a gas is much smaller than the average separation between the molecules. Already I have discussed this one. The size of the molecule is much smaller than the average separation between the molecules. Separation is larger, but the size is very, very small. Then the molecules of a gas are always in a state of random motion with varying velocities in all possible directions. So molecules are in the state of random motion with varying velocities in all possible directions. They can move freely. They can acquire any velocity. Okay, of course there should be less than velocity of light. Okay, finite velocity they can acquire, and they can move in all possible directions. Fourth point is the collision between molecules and with the walls of the container are perfectly elastic, and hence there is no loss of kinetic energy during the collision. Okay, so collision takes place between the molecule with the other, and also they can collide with the walls of the container if gas sample is put in a container. And collision takes place in such a way that the collision is perfectly elastic. That means there is no loss of kinetic energy. Okay, so total kinetic energy of the sample remains constant. Okay, if collision takes place, gas molecule can transfer the kinetic energy to the other. ಮತ್ತೊಂದಕ್ಕೆ kinetic energy transfer ಮಾಡಬಹುದು, but total energy of the system, total kinetic energy of the system remains constant. Okay, so this is the fourth point. You can take the screenshot, then we'll move further. Okay, then next point. Fifth point says the molecules of gas obey Newton's laws of motion. All molecules will obey Newton's laws of motion. That is fifth point. Okay, Newton's first law, second law, third law, they will be perfectly applicable for gas molecules. First law says about the inertia. Second law says about the relation between force and momentum, and third law says about the action and reaction. So they are applicable for these gas molecules. Sixth one, the distribution of the molecules in a whole vessel remains uniform as the molecules inside the container keep on moving continuously in all possible directions. So what it says, there is no accumulation of the molecules at a certain position or certain space. So the molecules will move continuously without stopping. Because of that, the distribution of the molecule inside the container is going to be uniform. ಅಂದ್ರೆ ಒಂದ್ ಕಡೆ ಜಾಸ್ತಿ molecule accumulate ಆಗೋದು, ಒಂದ್ ಕಡೆ ಕಡಿಮೆ molecule ಇರುವುದಿಲ್ಲ ಅಂತೇಳಿ. So they will continuously move in such a way that the distribution of the molecules in a container will be uniform, so that density of the molecules in a container will be same, constant. Density of the gas will be constant. In that way, the molecules will move. That is very important point. Density of the gas is constant. Okay, even though they are moving inside the container, they will move in such a way that they will keep the density of the gas constant. That is the sixth point. Seventh one, there is no effect of gravity on the motion of molecules, as the mass of a molecule is negligibly small. Okay, there is no effect of gravity on the motion of the molecules, as the mass of the molecule is negligibly small. So already I have told you there is no potential energy. Gravitational force will not affect the movement of the molecules because of their very small size. Okay, compared to their size, velocity of the gas molecule is larger. Because of that, the total momentum will be greater. Mass into velocity. Mass is smaller, but velocity is greater. So that momentum of the gas molecule is greater, and gravitational force will not affect the motion of the gas molecule. That is one assumption. That means potential energy will be zero. It shows only kinetic energy. Okay, so that is the point. Next, the intermolecular distance between the molecules of a gas is much larger than that of a solid or liquid, and molecules of a gas are free to move in a space available to them. So again, it is linked with the seventh point. Eighth point is linked to the seventh point. Intermolecular distance between the molecules is larger. So distance between the molecules is larger. Okay. Because of that, molecules are completely free to move. Between them, there is no interaction. There is not completely free to move. Okay, they will move. Point number 5 to 8. Okay, next we'll move. Ninth point. The molecules do not exert force on each other and on the walls of the container except during collision. Okay, so what it says, so during their free motion, they will not get attracted or repulsed by other molecules. Okay, so they will experience a force when they collide with other molecules, and that force, if other molecules or if they collide with other walls of the container, at that point of collision, they may experience a small force. Okay, for change in momentum of the molecule, and reaction will take place. Because of that, there will be the definite, exactly equal change in momentum is going to take place. Okay, ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, ಮತ್ತೊಂದು molecule momentum ಏನಾಗ್ತದೆ, ಜಾಸ್ತಿ ಆಗ್ತದೆ. So that is going to take place. So that total momentum is going to be conserved. That is in accordance with law of conservation of momentum. Okay, law of conservation of momentum will be applicable, or it is valid in case of collision of molecules also. Then 10th point says the molecules travel along a straight path between two collisions. The distance covered between two successive collisions is called as mean free path. Sorry. Okay. So molecules travel along a straight path between two collisions. The distance covered between two successive collisions is called as mean free path. This is very important. So during their motion, the total distance covered between one collision to next collision, that is called as two successive collisions. That is called as mean free path. Let us say molecules move from one point to another point. Between that motion, it may collide with number of molecules. Let us say 100 collision takes place. Okay, while molecule covers total 100 meters. Okay, 100 meters will be covered by a molecule. During that course of motion, it collides with 100 other molecules, or 100 times it collides. So what is the mean free path? That means what is the distance covered between two successive collisions? That is equal to total distance moved divided by total number of collisions. Total distance moved is 100 meter. Total number of collisions will be 100. Okay, 100 meter by 100. So mean free path will be 1 meter. Okay, that means after every 1 meter distance, it will collide once. Okay, that is the meaning of mean free path. So up to 1 meter, it will move freely. After 1 meter, it will collide with other molecule. Then after 1 more meter, it will move freely. Then collision will take place. Okay, that is the meaning of mean free path. So it is the distance covered between two successive collisions is called as mean free path. Then last point, 11th point, the time of collision is negligible as compared with the time taken to cover the mean free path. So that means the collision, time of collision is going to be instant. It is sudden. Okay. So there is no consumption of time during the collision. Only during the motion, it may consume the time, but during the collision, at the time of collision, it will take place very instantly. Okay, that is the time of collision is negligible as compared with the time taken to cover the mean free path. So it will move freely for certain time, then instantly it will collide with other molecule, and then it move freely again. Only it will change its direction after the collision. Okay. So because of that, it will move randomly, it will move continuously. So this is the 11th point. You can take the screenshot. This is about the assumptions of kinetic theory of gases. Then we'll